Hi, my name is Doguhan Uluca, and I'm a technical fellow at Acela in Washington, D.C., and I'm also a GDE in Angular. Today I'll be talking about crafting reliable and testable code with TypeScript. But first I want to talk to you about the importance of our job. This is the Tacoma Bridge collapse from 1940, where the engineers kind of miscalculated the wind loads that the bridge can handle, which resulted in the collapse of the bridge on opening day. And today, the work we do on projects that we work on are very important infrastructure projects that impact a lot of people. So I want you to take this talk about creating reliable applications kind of very seriously. We are doing our jobs because we want to create value, but we need to create quality value. And so in the golden triangle, we know that we can only pick two of features, time, and quality. And for the most part, quality is the first one to go. So we have to focus on keeping quality, and unfortunately we can't control time. So the only thing we can control is the amount of features that we implement. And so the amount of features that are implemented are managed in various ways, like Lean, Common, Scrum methodologies, less safe, Spotify. Yes, that's the real thing. And so it's extremely tough, even when using these methodologies, to create consistent forward flow of features. And no matter what manager or team lead kind of does, it's very difficult for this to be a top-down process. It has to be a bottom-up process where every engineer on the team has a quality mindset, because it's up to us to deliver quality and working code. So your clients, your bosses, they're going to want features. So you have to kind of learn how to say no and put up a different no face from day to day, because you can be the best engineer in the world, but if you don't know how to say no, then you're not going to be able to really deliver quality work. So it's up to you. So keep that in mind as we go through these best practices today. So we'll be talking about high cohesion, low coupling, dry, KISS, AC/DC principles, self-documenting code, unit testing, solid principles, stateless and data-driven design, shifting complexity to the back end, iterative and incremental design, and embracing reactive coding. So why TypeScript? TypeScript is JavaScript at scale. So if you're doing any kind of JavaScript, you should be using TypeScript. It is a development time tool only. So whenever you ship your code, it is JavaScript. It offers optional type checking, so you can use it as much or as little as you like. It also adds types to existing JavaScript libraries, so working with them becomes a breeze. It also supports object-oriented and functional programming concepts, which are pretty important in writing quality code. It also covers the JavaScript feature gap. So what is that? So at any given time, there's the most compatible version of JavaScript that's supported by most browsers, and then there's the best, developer-friendly version of JavaScript that makes us the most productive. So it's basically there's this battle between the past, present, and future of JavaScript at any given time. So this is the JavaScript feature gap, and TypeScript, along with other transpilers out there like Babel, they cover this gap. And over the years, we've seen this feature gap kind of shift, and there's no end to it. So tools like TypeScript or Babel, they're going to be pretty useful. But one thing that separates TypeScript from the pack is, of course, you can use it in the full stack and with great success. And on the client side, you can use Angular, React, Vue, what have you, with TypeScript, and you can code your view models and your models in TypeScript, and on the back end you can code your entire architecture using TypeScript. So this actually eliminates context switching when a developer is switching back and forth between the front end and the back end, which is a great cost saving. So today I'll be referencing 3 apps: the local weather app, Lemon Mart, and Lemon Mart server, which I've developed alongside 20 plus other open source libraries and projects that supports the content I'll be talking about today. So first, let's talk about high-level goals. So high cohesion and low coupling. What is this? So we want our applications to be highly cohesive. So basically, this means keep the code that belongs together. So if there's a banking domain, keep all that banking domain code in the banking module. Don't spread it out. And low coupling means don't expose the inner workings of your file or class or function outside, because if you do, then you tightly couple your code and you will not be able to refactor or replace any part of your code going forward. So a good example of high cohesion is, as we see here, in a monorepo, we have the web app code in one folder, then we have server, and it has models, public folder, services, and various routes. So the code that belongs together stays together. In a low coupling environment, if we consider this rater component, we can see an internal value of number that keeps track of the rating, and we can add the private property to internal value to hide it from the outside, because if we don't do this, then anyone can come in there and manipulate that value. However, we want to control access to this value, because we have the set rating function that has an intricate set of steps there that controls how the rating is set. And then and we can also refactor our code so that we don't have to repeat ourselves, which is the drive principle. So you should not repeat yourself when you code. Don't repeat yourself, and don't repeat yourself. And the KISS principle is keep it simple. Let's just leave it at that. Don't overcomplicate your solutions. The AC/DC principle, I just came up with that earlier today. Avoid complexity and depend on your own code. So don't bring in a library for every little need you have. Just write a function or two and share your code across your projects, and don't keep adding piles and piles of complexity. So export reusable functions, avoid libraries, avoid overusing dependency injection. So what does this mean? This is an example of a validation. So if we want to be able to share validators across our application, we need a fancy library, right? Not really. All we need is a simple TypeScript file, and then just export our validation configurations, which are just arrays, and be able to use them anywhere we like. This applies to any front-end technology or back-end technology. And then another example here is this auth service, where we have a create JWT function that we can just export out of this file. We don't have to use classes or anything like that. An authenticate function that we can just share and use. And while doing this, we can also keep the inner workings of our file still private, because the sanitize token function is not actually shared. It remains private to that file. Another example we have here is this fine with pagination function. It's a helper function that I wrote that just makes it easier to kind of work with paginated queries. I don't need a whole library, a massive library, to help me paginate my database requests. And then next thing is we want to be able to work with self-documenting code. Code is written once and read many times, and once written, documentation is never updated nor read. So we need to write verbose code, and we need to create living and useful documentation. Also, no string literals. Never string literals. No string literals. I mean it. All right, so how do we create self-documenting code? So this is an example of this Swagger tool, where we can kind of document the kinds of inputs our web request can accept. And then here we can say what type of web request this is going to be, a GET request, and then what kind of parameters it will take, and what kind of response it will return. And at the very end here, you can really see this is just documenting the use of 2 lines of code here. And at the end of this, using Swagger, we can get this nice interactive website where not only documents our API, but it also can be used to test our APIs. So it's a very useful tool. So once again, here you can see this is the amount of total code. The top part is just documentation, and the bottom part is code. Yes, write more documentation than you write code, but write functional, useful documentation. So next up is readable code. So this is a pretty common mistake I see in creating TypeScript applications. These nondescript parameters and generic arguments where you're kind of like looking at this code. Okay, it's some cursor, there's some query with parameters, and then some projection, another cursor, another query. What is going on? It's not clear at all. You have to inspect it real hard to understand what's going on. So here's another version of it where we can actually see that the generic is meant to be for the return type, and then the cursor is actually an aggregation cursor, and then the other generic is actually meant to be a document type. And then here we can see it's actually building a tokenized query object. And here we're actually seeing that it's in the prior segment it was returning an aggregation cursor, and here it's returning a regular cursor, processing a pre-built query. So you know, our computers have enough memory nowadays, so we can really you know, expand our variable names. And also one of the other features of TypeScript are enums. So we don't want any string literals in our code. We really don't want any string literals in our code. So use enums instead of string literals, please. This will save you from many, many bugs. So in short, TypeScript helps us write readable, dry, and simple code. So let's talk about unit testing. A test-driven development mindset is the most important mindset you can have in terms of creating quality code. It forces deeper thought about design of your code. It ensures testable code is written, and it avoids over-engineering. So even if you don't write too many tests, make sure you at least write testable code. A way to write testable code is red-green refactor development, which is first writing a failing test, getting it to pass, and then refactor it, and then repeat the process. So with unit tests, the first principle is critical. Unit tests have to be fast, isolated, repeatable, self-verifying, and timely. There's not much use writing unit tests 3 months after you wrote the code. It has to be written kind of around the same time, or at the same time, or before you write the actual code. So if we look at Mike Cohn's testing pyramid, you can see at the bottom, unit tests are the fastest and the cheapest kinds of tests we can create. So you should have thousands of unit tests in your project. And the other kinds of tests, less so, because they are more and more fragile, whereas unit tests are super reliable. So keep your tests organized. They focus on a single class, file, or function at a time. So a unit test has 3 parts. It has an arrange, where you set up your dependencies, an act, where you run the thing that you want to test, and then the assert section, where we verify the results. So here's an example where we're testing the get current weather function given a zip code. So we have an arrange block, an act block where we're actually getting the current weather, and then an assert block where we're testing our expectations. So isolating dependencies is very important. We have a weather component that wants to talk to a weather service, which wants to talk to a weather API. So the test harness can help us actually isolate these external dependencies. By using a weather service mock, we can fake a get current weather function and tell it to return 32, and then we can even inspect or spy to see if a call was attempted to be made to the weather API. So here, if we look at it again on the arrange, we're actually setting up a return value for a postal code, and we're setting up the object that we're expecting. Then we're making the actual call, and then here we're spying the fact that, hey, this URL was actually called in the manner that we expected it would be called. So TypeScript helps us write precise unit tests. Next, I want to talk about solid principles. Solid principles are the S stands for single responsibility principle. This is basically the drive principle, and the point is you should only be changing code in one place. So basically, if you fix a bug, you should only have to fix it in one place. And there's the open close principle, which means your code should be open for extension but closed for modification. There's the list-conf substitution, where objects derived from base or abstract classes should be able to leverage the code without knowing about the specific implementation of those abstractions. Interface segregation is about many specific interfaces over one general purpose interface. So you should never have like an iData interface or a database interface that just contains all of your types. And then dependency inversion is about depending on abstractions and not concretions. So this is about passing interfaces instead of classes in between your services and components. So here we have the Lemon component back again, and this time from a single responsibility perspective. So this is the set rating function. So this is looking a little bit different because it's doing everything that can be done. It's interacting with the DOM. It's finding what text should appear given the rating, and it's making all the other calls. And then we have a set display text that's also doing a lot of things, and it's not obvious here, but we're actually duplicating the code from line number 8 and line number 24. And basically, if we rewrite this, and every function has one purpose, value returns just the internal value, set rating actually does its own thing, and then set selected text here interacts with the DOM, and then we can reuse that elsewhere, so we don't have to repeat ourselves. And then this get selected value actually decides what the text should be. And the whole purpose of breaking our code into so many functions is, one, we can write much easier unit tests with them, but ultimately it makes the set rating function a breeze to read. Anyone looking at it can quickly tell what's going on with this code. All right, the second is the open closed principle. So here I want you to take a look at a set of abstract classes. We have an auth service that depends on a cache service, and then auth service implements the iAuth service interface. So the goal here is so that we create a base auth service, and then we can implement multiple authentication providers like Firebase, a custom app server, or even an in-memory one for testing purposes. So here is the interface for this. There's an auth status, current user, properties. There's a login method that takes an email and password, a logout method, and a get token. So just given this interface, we can go ahead and define an abstract class. We don't have to implement anything, but just given this, we can go ahead and implement the entire authentication system of our application, just depending on these interfaces. No concrete implementation necessary. So here we have our abstract class, and within our abstract class we can define abstract functions of an auth provider implementation that takes an email and a password, a transform JWT token function, because every service kind of deals with this slightly differently, and also a get current user function to be able to get the current user from the current auth provider. So in our abstract class, we can then based on these kind of imagined features we can implement a login method. And here we can call our auth provider, transform JWT token function, and even get current user function. We don't need to know the specific implementations of it. And this is the part of our application that is close to modification. That's not going to change, but it is open to extension, because then we can actually extend auth service with an in-memory auth service, and then we can implement auth provider, transform JW token, get current user. We can do this for Firebase, we can do this for our custom server, and all of these will work within our application without us having to change any code. And then on top of that, we can have an authentication factory based on a configuration element within our application. We can then dynamically inject whichever auth provider we like at the startup of our application. So next up is interface segregation. And this is about just liberally using interfaces across your application without creating one, massive interface called like, iData or iDatabase. We can have iUser, iCurrentWeather, our current weather data, etc. So in this case, the current weather data is the shape of the data on the server, and then the iCurrentWeather is the one that's used within our app, which is much simpler. So in summary, to write unit testable code, be sure to adhere to at least the single responsibility and open-close principles of the solid principles, and you'll be good to go. So TypeScript enables solid code, refactory code, so you can export reusable functions, pass around abstractions, use enums instead of string literals, use interfaces to document the shape of your data, use classes to reuse context-specific behavior, use abstract-based classes to enforce implementation patterns. And all of this is going to set you up to be able to begin managing complexity within your application. So imagine this kind of complicated data model here, and there's a user object in there that we're going to focus on. So interfaces document the shape of the data. So here's an example, a user interface with an address, name, phone, etc. So when creating interfaces, aim for a flat data hierarchy, because you want to separate your presentation as much away from your database as possible, because your database can change. So you want to keep your front-end code as simple as possible. So flatten as much as possible. Arrays and simple shapes and common shapes like address, name, etc. They're kind of fine. And also prepare interface types with a capital I. Otherwise, you don't really know if you're working with an object or an interface. So and work to keep complexity in the backend. And an example here is the same iUser object, but this time on the server side, because you can see it extends an iDocument because it's also a database object simultaneously. So it's a lot more complicated than the front-end version, because you can see all these document TS, MongoDB, bcrypt.js dependencies it has. And because of these reasons, don't share models between front end and back end. They're there for entirely different purposes. The user model on the back end has to deal with setting passwords, salting and hashing and comparing passwords. So it contains secure code that you don't want to share with the front end. So move your business logic to the back end as much as possible, flatten your data hierarchy, and consider tools like GraphQL when appropriate to kind of simplify your implementation. So looking at this user model also, we can implement features like full name as a property getter in a class, so we don't have to keep re-implementing this concept of bringing together first, middle, last name, and then prefixes and suffixes and all that stuff. We can just implement it in one place, and then we can just implement an API function that just returns full name, email, role, etc. And that way we're actually even sending less data across the wire. So we want to write stateless code, so no class properties, no global variables, We want to keep a data-driven design, and one of the most key things here is what you avoid implementing is more important than what you actually end up implementing. So keep things minimal. TypeScript helps us manage complexity. Let's talk about quickly iterative and incremental design. So if we were implementing a login experience, we start with a design, right? What's the first thing we do? Just replicate the whole thing? Not really. The first thing we do is just implement a simple login button. You click on it, it just pretends that it logs in. After you start fleshing things out, then go in there and implement the full login experience. So implement things iteratively and incrementally. This is gonna save you from over-engineering. So we want to be stateless, composable, and reactive. I want you to think about turning the faucet on and getting some hot water out of it. So in the imperative coding style, we need to first put water into the pipes and then direct water into the heater and then make an API call to the utility company to turn on the power. And then we need to turn the heater on and then wait for water to heat and turn on the faucet for hot water. And then don't forget to undo your steps when you're done. How many event leaks or memory leaks or water leaks is this gonna lead to? With reactive programming, it's very simple. You just turn on and off the faucet for hot water. But what does this mean? So here is a bit of code that retrieves a product from a server. And here, we can tap into that stream and stringify the data. We can catch errors. We can cache our results. But then when we need to write some code to get products by category, we can actually reuse the code that we just wrote, but merge it with a product category stream. And then by using these streams together, we can then actually find products of categories that match, and then get a product type with the correct categories, and then we can still cache our results here. So TypeScript makes it easy to be stateless, composable, and reactive. So in summary, we have high cohesion and low coupling, dry, KISS, AC/DC principles, self-documenting code, unit testing, solid principles, stateless and data-driven design, shifting complexity to the back end, iterative and incremental design, and embracing reactive coding. So all these together, with the power of TypeScript, if you write unit testable code, if you manage complexity, be reactive, iterative, incremental, you'll be creating reliable web applications. And don't forget to keep it simple. Thank you very much for listening to my talk today. Check out my book, Angular for Enterprise-Ready Web Applications, for all this content and more. And also check out my VS Code extension, Angular Evergreen, to keep your Angular projects up to date. Thank you very much.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.